Dear students, now we are going to discuss the feedback concept, its types and its gain analysis.
Feedback concept is a technique in which the portion of the output signal is fed back to the input side and combined with the input signal to produce the desired output. Here the portion of the output signal given back to the input side is known as feedback signal. The feedback signal is either in phase or out of phase with the input signal. Based on that, we can classify the feedback system into two types, positive feedback and negative feedback. This is the basic structure of feedback system. It has two important circuits, amplifier circuit and feedback circuit. The portion of the output signal is fed back to this input side to get the desired output. Okay, here Vs represents source input signal. Vf represents the feedback signal from this feedback network. Vi is the actual input given to this amplifier. V0 is the output signal. Okay. Next, types of feedback. Positive feedback or regenerative feedback. Negative feedback or degenerative feedback system. So in positive feedback, the feedback signal is in phase with the input signal. So the feedback signal is added with the input to get the desired output. In negative feedback, the feedback signal is out of phase. Okay. In negative means out of phase with the input signal. Here the feedback signal is subtracted from the input signal. Okay. Next, we are going to derive gain of feedback amplifier. For that, we can consider the basic structure of feedback amplifier. So, this is the basic structure. It has two important circuits, amplifier and feedback network. So, the gain of this amplifier A is equal to output by input. The output for this amplifier is V0. Input is Vi. So, V0 by Vi. Gain for this feedback network is beta, that is equal to output is Vf, input is the portion of output, that is V0. So here beta is equal to Vf by V0. So what about the overall gain of this system? So this is the gain for this amplifier, this is the gain for this feedback. What about the overall gain? That is represented as AF. Okay, so the gain of the amplifier with feedback, that is equal to output is V0, the actual input to the system is Vs. So AF is equal to V0 by Vs. Here, what is the value of this Vi? Vi is the actual input given to this amplifier. This Vi can be obtained by adding or subtracting this feedback signal from this Vs. So we can represent Vi is equal to what? Vs plus or minus Vf. Okay. Let Vs is the source input voltage. Vi is the actual input applied to the amplifier. V0 is the output signal. Vf is the feedback signal. The gain of the amplifier circuit is A is equal to V0 by Vi. From this we can get V0 is equal to A into Vi. That is the first equation. The gain of the feedback circuit is beta is equal to Vf by V0. From this we can get the feedback signal Vf is equal to beta into V0. Consider this as the second equation. Okay. Next, the input given to the amplifier is Vi is equal to Vs plus or minus Vf. Here plus represents positive feedback, minus represents negative feedback. Next, we can substitute the value of this Vf as beta V0 from the second equation, and then this V0 can be replaced with the value A into Vi from first equation. Next, we are going to obtain the value of this V. For that, we can move this value to the next side. So, this term becomes Vs is equal to Vi minus plus A beta Vi. So, next Vi is a common one. We can take it outside. Vs is equal to Vi into 1 minus plus A beta. This is the third equation. So here the overall gain of the feedback amplifier is nothing but V0 by Vs. We are going to substitute the value of this V0 and Vs from the first and third equations here. So V0 is nothing but A into Vi. Vs is nothing but Vi into 1 plus or minus A beta. So Vi divided each other. Here AF represents to loop gain, that is with feedback system. A is the open loop gain. Finally, the overall gain of the feedback amplifier system is equal to A divided by 1 plus or minus A beta. Here the denominator value is denoted as desensitivity factor. This is the general formula. In case of positive feedback, we can get the value as A divided by 1 minus A beta. In case of negative feedback, we can get the value as AF is equal to A divided by 1 plus A beta. So next we are going to discuss this positive feedback and negative feedback in detail. As we have already discussed, in positive feedback system, the feedback signal is in phase with the input signal. Here the feedback signal and the input signal both are added to get the desired output. So here we are going to add the source input signal with the feedback signal to get the input to this amplifier. So Vi is equal to what? Vs plus Vf, and then we can replace this Vf with the term beta into V0 from the second equation, okay? Then we can replace this V0 with the value A into Vi based on that first equation. We are going to find out the value of this Vs now. So keep that value here and move the remaining terms to this side. So Vs is equal to Vi minus A beta Vi. Vi is the common term. We can take it outside. Then the remaining terms are 1 minus A beta. So the gain of the positive feedback system is AF is equal to V0 by Vs. That is output by source input. That is equal to V0 is replaced with the term AVI. Vs is replaced with the term Vi into 1 minus A beta. So Vi divided each other. Then we can get the gain of positive feedback system as A by 1 minus A beta. So you have to remember this. For positive feedback, the gain is A divided by 1 minus A beta. So here 1 minus A beta is the desensitivity factor of positive feedback system. Here the closed loop gain is greater than this A, that is divided by 1 minus A beta. So it is greater than this A. Hence it is called as regenerative feedback system. If this A beta approaches unity, if it is approximately equal to 1 means what will happen? This term becomes infinite because A divided by 1 minus 1, 0. Anything divided by 0 is nothing but infinite. Correct? That's what given here. If A beta approaches unity, then AF becomes infinite. It means the circuit produces an output without any input due to this high gain. Hence, the positive feedback is widely used in oscillator circuit. Next one is negative feedback system. In this method, the feedback signal is out of phase with the input signal. Hence, the feedback signal is subtracted from the input. So, here we can get Vi is equal to Vs minus Vf. So, here it is the source signal. Here it is the feedback signal Vf. We are going to subtract this feedback signal from this source signal to get this Vi. So Vi is equal to Vs minus Vi. Beta into V0. Then V0 can be replaced with the term A into Vi. Next we are going to obtain the value of this Vs. For that we can move this term to the another side. So Vs is equal to Vi plus A beta Vi. Vi is the common term here. So we can take it outside. Vi into 1 plus A beta. Finally, the gain of negative feedback is equal to V0 by Vs is equal to AVi by Vi into 1 plus A beta. We can divide Vi value and then the gain is equal to A by 1 plus A beta. So that is very important. This is the gain of negative feedback amplifier. If the desensitivity factor 1 plus A beta is greater than 1, then the closed loop gain, that is the gain of amplifier with feedback, reduces from the gain of amplifier without feedback. Correct? Hence it is called as degenerative feedback. If A beta is far greater than 1, then the closed loop gain becomes A by, that 1 is negligible 1, we can ignore it, A beta. So A divided, finally we can get AF is equal to 1 by beta. Then the closed loop gain of negative feedback is entirely depending on beta alone. That is the feedback network. So it provides very high stability. Do you all understand? If the gain of the amplifier depends only on the feedback, then it is not affected by the temperature variations or variations in transistor parameters and frequency changes. Okay. So it can provide very high stability. So that's why we can use this negative feedback in amplifier circuits.